So, couple reminders to solve for the length of a side. It's distance formula or Pythagorean theorem. We've covered those too. Now, there's a way to solve for an angle on a coordinate plane, but only if it's a right angle. And that's what happens if you have perpendicular lines. Perpendicular means that they cross a 90-degree angle. So, lines are perpendicular, they create 90-degree angles if their slopes are opposite reciprocals. And here's what that means. Opposite means if it's positive, it's going to be negative. If it's negative, it's going to be positive. Reciprocal is flipped. Meaning if it's 1 over 4, it's going to become 4 over 1. 3 over 5, it'll be 5 over 3. So an example of this, if I have 3 over 4, what does that become? So I heard 4 over 3, and you need the negative. Good. Because now it's the opposite, so positive and negative, and it's flipped. And the last one. If I have negative 4, what did that become? 1 over 4, a positive 1 over 4. Because don't forget that there's actually an imaginary 1 under it. Alright, the only angle you can measure is a 90-degree angle. Therefore, your only options of congruence are: what are my 5 options for triangle congruences? What are the 5 shortcuts? Side, side, side. Side, angle, side. Angle, side, angle. Angle, angle, side, and H out. Can a triangle ever have 2 right angles? No. So if you can only find right angles, how many angles can you actually find per triangle? 1. You can only find a right angle. Therefore, you won't use this one or this one for this problem, because it only gives you the option of finding 1 angle. Now on problems ahead, they're going to say, here are these 2 triangles, prove that they're congruent given this, given maybe 2 angles are congruent, given maybe 2 sides are the same. So you can use that information, which means less work for you, but your options can still be limited. So don't forget, whatever method you choose, you must show me all the work for it. So which angles look like they can be right angles in this problem? So angle PRS, which is R, and which other one in the other triangle? And B, or ABC, which is B. So we're going to prove that right now. I'm going to show the work here for my slopes. So it says, if that angle B is going to be a right angle, then these 2 lines here have to be opposite reciprocals in the slopes. And how do you find slope from a picture? That's to find the length. To find the slope, you count what over what? Rise over run. So, let's find AB. From A to B, how many did I go up? 3. That's my rise. What's my run? So it's 3 over 3, which reduces to what? 1 over 1. Keep it over 1. So that one has to be the opposite of which one? BC. What's BC? 3, 4, 5, 6. What's my run? Six. And what's my rise? I'm going down now. -6. I'm going down. So BC will be a -6 over 6, which reduces to what? -1 over 1. Are the opposite reciprocals? Yes. What does that mean about angle B? Angle B is 90 degrees. So we can actually draw that in now, that little box. Which other one needs to be a right angle now? R. Let's count it really quick. Let's find PR and RS. Since they're opposites, that means that angle R is also 90 degrees. So, if two angles are 90 degrees, what does that mean about those two? They are what? Congruent. Good. You found one piece of information so far. You found congruent angles. Now we have options. We can just say ignore the angles and do side, side, side. We can say I found the angles for a reason, so let's do side angle side. Or I can use that angle and find hypotenuse leg. Which one do you guys want to do? Doesn't matter to me. Side angle side? That works. For my sides now. If I'm doing side angle side, which side has to be congruent to which side? BC and RS. So let's find those two. BC equals and RS equals. What form is probably the easiest to solve? Pythagorean theorem. BC, you already know, is 6 and 6. So it's going to be 6 squared plus -6 squared equals c squared. What's 6 squared?
36.
What's 36 and 36 make?
72.
72. Therefore, c is the square root of 72. Let's find RS. See if it matches.
That was RS, right?
No, that was BC. RS is how much?
RS is 6 and 6.
6 and 6. Is it going to match?
Yeah.
Yeah, they're the same numbers. Therefore, it is square root of 72. What did we just prove right now?
This side is congruent.
That this side is congruent to this side. We have a side, we have an angle. Which side is missing now? PR with? AB and PR. Let's find my math. What two numbers for AB? What are my A and B? Sorry. 3 and 3. What's 3 and 3? What's 3 squared make? 9. How much is C? Good. Sorry, that's extra small. Find it for PR. What are the two numbers? -3 and 3. Does a negative actually matter? No. If they're the same number, we get the C as a square root of 18. Do they match? Those two match. Therefore, I'll go back and show the work in a bit. AB is congruent to PR. Let's put 2. And let's just organize our answer. We want to prove side, angle, side. So give me one pair of congruent sides that we proved. RS with what? RS is congruent to BC. And we proved that with this one. Next, I need an angle. What angles do we prove are congruent?
R and B.
Angle B is congruent to angle R. And lastly, what's the last side we proved? PR is congruent to AB. And we proved that with the green one. Therefore, triangle ABC is congruent to triangle PRS by this is your answer. Everything I just circled is your answer. Everything else is the work to prove it. So you can see why I say the work is important if you expect to get credit on this. If you don't have the work, you just guess, I can't give you any points for it. So now the triangles are drawn and I'm giving you this information. What should you do with your picture right away? Go through and mark it. Mark DE and KJ as being congruent. Do any angles look 90 degrees? No. Therefore, you can't do HL. You can't do side angle side. Because you can't prove that they're 90 degrees if they don't even look like it. So what's the only option you can do for this problem? Side, side, side. So here's what we're going to do. We're going to find EF and we're going to find DF. Because if we know these three, then we have to figure out if the other ones match it. If we find one that doesn't match, they're not congruent already. So, EF, what are my two numbers for my rise of a run? 1, 2, 3, 4. And 1, 2, 3, 4, 5. -5. For EF, I have 4 squared plus a negative 5 squared. 4 squared
That's 16.
plus,
25.
what does that give me?
That would be 40.
Therefore, that amount is a square root of 41. DF, what can I do with DF?
You can.
Do I have to do Pythagorean theorem? Why not? You can just count it. It's a horizontal line. How many is DF?
6.
DF is 6. Now go to the bottom triangle. HJ is how much?
5.
Is that an issue already?
Yep.
What happened?
It's not congruent. 2.
5 doesn't match 6. It doesn't match the square root of 41. And we know this one won't be the same as this one because these two are already the same. So, we're going to write that all 3 sides don't match. Therefore, what? The triangles are not congruent.